Welcome back to Algebra 1 with me, Miss Killen, here at MPB. I'm so glad you came to learn with us today. I want us to look into some functions, some intro to some functions. We're looking at IF1 and IF2. We can determine if a relationship is a function. Now, some vocabulary that is crucial for these relationships and functions are our domain, which is our x values or the inputs, our range, which is our y values and our outputs. A relation is a collection of inputs and outputs. They have some type of relationship. And then a function is a rule that takes a mathematical relation where I have an x, which is my input, and I only have one output, which is my y value. So let's take those contexts and let's show what that looks like. What exactly does a relation look like? If I have some inputs, 3, 4, 7, 9, and 12. When I plug my input 3, I get a 5. When I plug my input 4, I get a 6 and a 7. When I plug in 7, I get a 12. When I plug in my 9, I get a 13. And when I plug in my 12, I get a 17. Now these are inputs and outputs. And you're probably sitting there asking yourself, well, it just looks like y's and x's, x's and y's. I don't understand why it's not a function. Let me show you. I have 3, my output is 5. 4, my output is 6 and 7. 7, my output is 12. 9, my output is 13. 12, my output is 17. Now the reason we say this is a relation and not a function, I can't do the same thing and get two different outcomes. I can't pass a test but also fail a test at the same time. When you have a relation, you have inputs to outputs. But if we look at a function, I have one input gets me one output. So when it asks me, is this a relation or is this a function? This is just a relation because I have one input that gives me two different outcomes, and that can't happen in a function. Ways we can see relations and functions. This first is called mapping. We just use the mapping. It looks for my x values and my y values. For a relation, I'm going to have multiple outcomes for one input. We can also see those same inputs and outputs in a table. Here are my x values and my y values. 3 to 6, 3 to 7, 4 to 7, 9 to 7. Now one thing that we need to look at, when I have outputs, I can have the same output, but I cannot have an input and get two different outputs. Ms. Killen, that doesn't make sense to me. Let me show you. If I have 3 cents, I can't have 60 cents and 70 cents at the same time. If I have 3 coins, I can't have 60 cents or 70 cents at the same time. If I have 4 coins, I can possibly have 70 cents. Or if I have 9 coins, I can possibly have 70 cents. But I can't have 3 coins and have 2 different outcomes with it. That's why this is called a relation and not a function. Now, let's look over here at the function. So you're telling me, Ms. Killen, those are relations because I put one thing in and got 2 different outcomes. But what does the function part look like? Let me show you. 3, 4, 7. I put in a 3, I get a 9. I put in a 4, I get a 12. I put in a 7, I get a 15. Every input has only one output. Everything I put in, I only get one thing out of it. That's what a true function looks like. So let's put that in table form. My x values and my y, I have 3 to 9, 4 to 12, and 7 to 15. So I have a mapping of a relation and a function, and then I have table of relation and function. Two different types to show me the relation, and then two different ways to show me the function. Or are there other ways to see, Ms. Killen? Let's look. Ways we can see relations and functions presented. Now, we've seen this. We know what ordered pairs are. Ordered pairs, we have x and y values, and we know what a graph is because we've seen a graph. But Ms. Killen, why are these on this side relations and why are these on this side functions? Let's look. I have my x and my y values. I have a 7 as my x. I have a 6 as my y. I have a 5 as my x. I have a 4 as my y. I have a 2 as my x. I have a -1 as my y. Uh-oh, I have another 5, but I have a different outcome. This is the difference between relations and functions. I can be a relation, but I don't necessarily have to be a function. All functions are relations, but not all relations are functions. So if I graphed these ordered pairs, Ms. Killen, what would that look like? Let me show you. 7, 6. We go over 7, 2, 3, 4, 5, 6, 7, and go up 6, 2, 4, 6, 5, 4. 1, 2, 3, 4, 5, up to 4, 2, -1. I have 5, 9. 1, 2, 3, 4, 5, and up to 9. I have two different y values on that x-axis, which is 5. That's why it's not a function. Because when I put a 5 in, I'm getting two different things out of it. That can only be a relation. Now, Ms. Killen, what about these functions that you have over here? Well, let's look. I have x as 7, y is 6. X is 5, y is 4. X is 2, y is -1. X is -1, y is 3. I have only one x to only one y. Well, Ms. Killen, can we see that graph? Sure, let's do that. 1, 2, 3, 4, 5, 6, 7, 2, 4, 6. I have 1, 2, 3, 4, 5, 4, 2, -1, -1, 3. So there we have for each x value, I only have that one y. That shows a function. Let's look at the graph a little bit more. Okay, we use graphs to determine if there is a relation or a function present. You must use the vertical line test. Now you're probably sitting there going, what is a vertical line test? Well, what is a vertical line? Vertical line is up and down, right? So if I use the vertical line test on my function, my vertical lines will only touch the graph one time. Let me show you. If I had a graph that looked like this, and I wanted to use the vertical line test to see if it is a function, I'm going to draw vertical lines. My vertical lines touch it once here, once here, once here, once here, once here. If those vertical lines only touch the graph one time, it is a true function. Well, Ms. Killen, what would it look like if it touched more than once? I'm glad you asked that. Let me show you. What if I had a graph that looked like this? Well, Ms. Killen, that's really weird. It's not straight. Some of our functions won't be straight. Some of our functions, like the quadratic or the exponential, they're not going to be straight. But we can look at those and this one to see if it's a true function using vertical lines. Let's look. So I'm going to start my vertical lines here. It touches once here. Uh-oh, it touches twice. It touches once. It touches twice. It touches once, twice, once, twice, once. Oh, Ms. Killen, it just touches once. It doesn't matter. through that whole graph, the vertical lines touch more than one time, so it is not a function. We would call this a relation. Another way is the equation. You can tell if an equation is a function by its features. Now you're probably sitting there going, features, what am I looking at? When you look at a human, you've got nose, you've got ears, you've got arms, you've got legs. Those are the features that show you that it's a human. Well, if I've got a function, I've also got features. I've got my slope and I have my y-intercept. Now my slope is how I go from one point to the next. My y-intercept is where I cross that y-axis. So this is a linear function or a straight line. I want to plot my b and use my slope to find my points. This is my b. We remember that y equals mx plus b. We're going to use it now. I'm going to let this be my x and y axis. This is my y and this is my x. This is my origin. So Ms. Killen, with this, how am I going to graph? Well, first I'm going to do what it says and plot my b. So it's a positive 3. 1, 2, 3. This is where it crosses that y-axis. So how do I get other points? I'm going to use my slope. Remember, my slope is rise over run. I'm going to rise 1 and run 4. Ms. Killen, what's that look like? Let me show you. I'm going to rise 1 and run 4. 1, 2, 3, 4. Here's my next point. To get another point, I'm going to do the same thing. Rise 1, 1, 2, 3, 4. Here is my linear function or my straight line. Well, Ms. Killen, are we sure it's a function? Let's check. My vertical line test is only touching the graph one time, so it is a function. Functions as equations. We're going to see y equals to show that it's a function, but we may also see other things. My y equals is the same as saying f of x, or maybe it would say g of x, and sometimes you may even see m of x. It's just telling you what your rule is, what your function is. I may be talking about forest trees or growth or maybe maturing rate. It depends on what you're talking about. It depends on what you will see as that y equals. We see y equals 1/4 x plus 3. It can also be seen as f of x equals 1/4 x plus 3. You can see many letters to show what these functions look like. We can do this. Let's do some practice. The following coordinates can be classified as either a function or a relation. So let's look. I'm going to go ahead and draw, and you do this on your paper as well, my x and y axis. Now I'm going to graph this. I have 1/5. I go over 1, up 5, 1, 2, 3, 4, 5. I have 6, 2, 1, 2, 3, 4, 5, 6, up 2. I have 7, 8, 7, 2, 3, 4, 5, 6, 7, 8. Then I have 9, 0. Is that a function or a relation? Well, let's see. If I connected them, could I use, it's going to be a function. It's not a linear function, but it is a function because I have one input to one output. We can do this as well. Let's look at this type of problem. Now, these are the type of problems that you're going to see. There's one key word in here. To make the following table represent a function, which number cannot be x value? I have -3, 1, -1, 3, 1, 5, 3, 12. What could go here that would not make it a function? Exactly right. If I put this -1 here, I would have two that have the same x input. That could not be a function if it was -1. Good job. Put the following inputs and outputs into the mapping. Now, when we do these mapping, we always want to make sure that we put all of our numbers in numerical order. Now, you're sitting there going, what is numerical order? 1, 2, 3 order. So let's do our number of trees. We're going to put them in numerical order. I see a 4, then a 7, a 12, and a 10. Now let's do our years from 2000. 0, 1, 2, 3. 4, I get 3. 7, I get 0. 12, I get 1. 10, I get 2. Is this a function? Absolutely. For every input that we put in this function, we get one output. Good job. Now, pause the video and you work on this with your table partner or by yourself, and let's see what we get. Awesome, you're back. Let's see what we got. Number 1 says, if P of x equals 1/2 x minus 4, using what we've learned of using our slope, graph 2 points. So I'm going to start with my B, which is -4, 1, 2, 3, 4. And I'm going to go up 1 and over 2. Up 1, over 2, up 1, over 2. Here is my graph. Is that what you got? Awesome. Let's look at number 2. Which ordered pair are on this graph? Now, Ms. Killen, that looks a little different than what we've been doing. You're right, but we have our calculator. Let's look at this calculator skill. Everybody pull up your calculator, and I want us to plug this into our calculator. I'm going to pull mine up here. Here's my calculator. It looks something similar to yours. All right, so let's put this into our y equal feature. I'm going to put 4 parentheses 3, and I'm going to raise that to the x. So I'm going to use my housetop and put x. Oops. And then I'm going to pull my table, second table. Now, it wants to know which ordered pairs are on this graph. So it has -1 and 4/3. So let's look up to -1. -1 and 4/3. Well, Ms. Killen, I have 1.33. Is 1.33 4/3? Yes, it is. So my first one is an answer. What about 0, 12? Well, here at 0, I get a 4. So that one cannot be on my table. The next one is 1/2 and 6. Well, Ms. Killen, I don't see 1/2 and 6. Well, I may have to go to my graph and see if at 1/2 if I hit 6. In this case, 1, 2, 3, 4, 5, 6, I do. All right, let's look back at the table. Then it says 2 and 144. Well, at 2, where x is 2, I get 36, so I know that's not. And then it has 4 and 324. At 4, I do get 324, so that is also on my table. So we've used a graph and we used our calculator skills. One thing I don't want us to forget, that mapping where I have inputs to outputs, how that looks when I draw my x's to my y's, what it looks like on a graph. Looking at those ordered pairs, how that looks on those tables, and using those vertical line and that vertical line test. All this determines if we have relations or functions. I'm so glad you came. Thank you for learning with us here at MPB. I'm Ms. Killen.